Personal finance practice problem using Excel. Present value calculation with monthly periods. Prepare to get financially fit by practicing personal finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet, would like to follow along, note that we're in the practice tab as opposed to the example tab. The example tab, in essence, being an answer key. Information on the left-hand side, going to populate that into the blue area on the right-hand side. The question says, how much would we have to invest to have in the future? 25,000, rate of return 24%, years 3 years, but this time not compounding yearly, but rather compounding monthly. So we want to have in the future 25,000, 24% is the rate of return. That then is the yearly rate of return, not the monthly rate of return. When we look at the tables, you'll be able to determine why we picked 24%. And if you're working in a school setting, you can get an idea of kind of the limitations that a school might have if they're trying to limit you to the use of the tables in the way that they format their problems. And then we got 3 years that we're going to have to break out into months. So let's first do that. We're going to say, okay, we're not compounding this yearly, we're compounding monthly. That means we have to calculate how many periods we have, which is going to be 3 times 12, or 36 periods. Now that already, when we do our running balance calculation, you can see how much more complicated that will be, because we're going to have to compound it 36 times as opposed to 3 times if it was compounded yearly. That then again is one reason that many practice problems will focus in and zero in on yearly calculations, even though many kind of real life settings compound monthly. So if you're in Excel, once you have the concept down, not really a problem to be able to copy and paste this information down for longer periods. Let's do the present value calculation. Note that this 25,000 is in the future. What we want to do is bring it back to the current time period to see how much we can put in today that would be earning 24% compounded monthly for 36 period or 3 years to get to that end period. That's why it's going to be a present value calculation. I'm going to do it fairly quickly because we've seen it before, but I'm going to highlight the new things that will be involved. The major things you want to keep in mind is that that rate that's been given, 24%, is usually a yearly rate. And that's going to be similar if you're talking about like a loan for a home loan or something like that, which you know is a monthly payment. Generally, they're going to quote it as if it's a yearly rate. They're not going to give you the monthly rate because the monthly rate could be quite small and confusing and whatnot. So they'll give it to you in a yearly basis. But when you do the calculation, you need the monthly rate, which means it's going to be that 24 divided by 12 in essence. Now, again, the software can do that quite easily. So let's see what that will look like. It's going to be negative to flip the sign, present value, shift 9. Then we'll pick up the rate, which is going to be that 24. But that's the yearly rate, and we're doing monthly periods. So now I got to divide that by 12. That's the new thing that we got to do in terms of an Excel function, comma, number of periods. Now, it was 3 years. They might give you 3 years, in which case you would take 3 years times 12. Or we already did that here, which is 36 periods. So 36 periods, comma, and then the payment, that would be for an annuity. This is not an annuity, present value. This is a function of 1, present value of 1. So 2 commas, bringing us to the future value. The future value where we want to get to is the 25,000, picking up the 25,000 and enter. So we're at the 12,255 or 56 about. Let's add some decimals. Home tab number group, couple decimals. So we're at the 12,255.58. Okay, so then let's do this with a formula basis. So same kind of thing. This is what you would probably do in practice. And then you would probably want to do a running balance in practice. But before we get to the running balance, let's do the table that we're going to do in an Excel, but it'll be similar to an algebraic format, meaning we'll do the formula down here. So let's go ahead and hide these cells up top. I'm going to put my cursor on C, drag on over to E, right-click on those cells and hide them. We're going to look at this formula, which you could plug in algebraically. It's still just a straightforward present value. The future value over or times 1 over would be the future value of 25,000 over 1 plus R. But now R is not 24%, but 24 divided by 12. We need the R that matches the number of periods. And then to the periods of 36 periods, which are monthly periods, making sure that the periods then, 36 periods, match the rate, which is not the yearly rate, but the monthly rate. So in a formula, it would look like this. We're going to say, all right, here we got the outer column is the 25,000. We're going to bring inside this inner calculation as we have seen in the past for the denominator, which would be 1 plus the rate. But now the rate, this is the new thing, is going to be equal to the 24 divided by 12. Going to make that a percent. Home tab number, we're going to make it a percent. We can add some decimals, and it obviously rounds to 2 nice and evenly. Now, note that I used 24% so in part so that it does round nice and evenly to 2. You can see if we had a yearly rate of 5% or something like that, then the monthly rate would be something kind of ugly, something ugly to basically talk about, right? That's why a book problem will be kind of limited to something like a 24% if you're going to use the tables. Obviously, you can still calculate this in Excel without a problem, no matter if it was an ugly number or not. But also note that when you're talking about rates, that's why we don't use monthly rates when we talk about them, even though we'll be compounding monthly, because again, the yearly rate makes more sense. It's easier to deal with. So let's go ahead and underline that. We'll go to the Home tab, Font Group, and underline. There's our 2%, and then we've got we're going to call this the 1 plus the R, 1 plus the R, and this is going to be equal to the SUM, Shift 9, up arrow, adding those up, making that a percent. Home tab numbers, obviously that would be 1.02 and a decimal, or percentizing it 102%. And then we're going to take that to the power of n periods. Periods to the power of n. And n, another new thing here, is not 3 years now, but rather 36 months. And so as long as these months match up with the rate, same thing, rate, the monthly rate in this case, we're good. We're going to go Home tab, Font Group, and underline, and that's going to give us then the result of the 1 plus R, Shift 6, caret to the n periods, and that's going to be in the outer column, which is going to be equal to the 102%, Shift 6, caret to 36, and that's going to give us 2. Let's add some decimals. Home tab, numbers, decimalized. And then we're going to go to the Home tab, Font Group, and underline it. And that'll give us our present value. Finally, dividing this out, this equals the 25,000 divided by that decimalized number. Adding a couple decimals. Home tab, numbers, couple decimals, there we have it. So we got that same 12,255.58 again that we'd have to put down up front, compounding monthly for 3 years or 36 monthly periods at 24%, the yearly rate, which would be 2% monthly rate to get to the 25,000 after that time period. Okay, so let's go ahead and indent this. Selecting these items, Home tab, alignment, indent. Let's indent this one again. Alignment, indent. Okay, now let's do this again. This time, let's do our running balance table, which again, it's a longer period because we got monthly periods, but that's okay because we have what's known as a spreadsheet in Excel to makes it easy. So we're going to then put our cursor on F, drag on over to I, Fee, right-click and hide. Right-click and hide. And then let's do this one. I'm going to say this is just going to go from 1, 2, let's start at 0. 0, 1, 2, selecting those 3, and then we're going to autofill it, fill handle, dragging it all the way down 36 periods. No problem, because Excel, that's why. And then we're going to go to the Home tab, alignment and center. And then we're going to say that the investment that we're going to start with, which I'm going to recalculate again to start at the starting point and prove that we will end then at the 25,000. So I'm going to do it again, negative, do it with our formula, present value, Shift 9, rate is the 24, but then I got to divide it by 12 because I need the monthly rate, comma, number of periods is going to be not 3 years, but 36, 3 times 12, comma, and then the payment is going to be no payment. What am I doing? Two commas, because it's not an annuity. Future value 25,000, and there we have our 12,256 again. And now let's do our interest calculations, and we'll do just a couple of them here. We won't do it 36 times, and then we'll drag it on down with the autofill. So this is going to be equal to And I will do it a couple times because, again, this one will be a little bit different due to the 24% needing to be monthly rate. So in other words, if I took that 12,256 times 24, that would be the rate for a year, and I got to divide it by 12. And that'll give us the monthly amount. And I think it's worthwhile to kind of look at this two ways. Note that if I was to do this in a calculator for a problem, I would do it this way: 12,256 about times 0.24, and that would give us about this. There's rounding involved. And then that would be for a year interest if that was for a year, but it's only for months. So divided by 12, that would be the monthly amount. Or, and this is how you kind of think about it in Excel, you could take the 0.24, the monthly or the yearly rate, divided by 12, giving you the monthly rate, 2%, then times the 12,256. And you'll get to that same result about rounding involved. All right, so then that means the investment's going to equal the 12,256 plus the 245. Let's do it a couple more times, and then we'll go back and autofill it. So we're going to say this is now the 12,502 times the 24%, and then divided by 12. And then this is going to equal the prior amount, the 12,501 plus the 250. Let's do it two more times here. This equals the 12,751 times the 24%, but then divided by 12. This equals the amount above it plus the amount to the left. Now we're at the 13,006, and this is going to be equal to 13,006 times the 24% divided by 12. This will equal the 13,006 plus the 260, and so on and so forth. Now I'm going to delete this and do it again, but this time keeping in mind that we're going to autofill it down and making any absolute references that we have to do it. So we'll delete this, selecting this item. No, don't delete it, don't delete it. Oh, God, all that work. Gone. Okay, let's do it again. This is going to be equal to the 12,256 times the 24. That 24 is outside of the where I want to be here. I don't want it to copy down when I autofill. So I'm going to select F4 on the keyboard, putting a $sign before the B and 4. You only need a mixed reference, but an absolute will work. Then divide it by 12. That is a hard-coded or typed-in number. That one will continue on when I copy it down as well. And then this one is simply going to be the one above it plus the one to the left of it. It doesn't have anything outside the table. Therefore, I want them both to move down relative, so I don't need to do any absolute references there. Then I can just select these two. And once again, I don't care how many periods there are because I can just grab the fill handle and drag it down. Doesn't even matter. We can do a whole mortgage, 360 monthly payments for a 30-year mortgage, which we might do later, and whatever. I don't care. Why? Because Excel, that's why. And then we get to the bottom line here. That's going to be the 25,000. So we get the 25,000 proving to us that we do indeed start at the 12,256. If we compound monthly using this calculation, we get to the ending point, 25,000 there. Let's do it with our tables. So if we do the tables here, we got the investment. The investment's going to be the 25,000 that we're going to present value. Now, again, this is another one where you look at the tables. We've been using the tables, and I'm sorry I'm saying again a lot. I notice I'm saying again a lot. So if that's annoying anybody, I'm trying to stop. But we got the percents up top and the periods on the left. The periods before we've always saw it as years and the percents as yearly percents. As long as those two things match, we're okay. But this time we need 36 periods, which are monthly periods, and therefore we have to match the related percent, which needs to be a monthly percent, which would be the 24 divided by 12, which would be 2. Now, note that that if this was something like 5 or something like that, you wouldn't be able to find the percent here because 1, it wouldn't be even, and they only have even percents, and 2, it would be smaller than 1. So, because it's a monthly percent. So notice how severely limited the tables are when a practice problem starts dealing with monthly time period compounding as opposed to yearly compounding. That's why most book problems will simplify problems that might often be monthly in real life to yearly so they can force you to use the tables. That's not a problem when you're using Excel, but if you're forced to use the tables, it is a problem. So you'll see percents like 24%. because if I divide that by 12, that gets me a nice 2%, which is nice and even, that I can then use in the tables. Don't let that limitation make you feel like that's a real limitation in life, because normally people don't take your calculator away or your Excel worksheet when you're doing stuff, and so it's not a problem therefore. But when you're in a book problem, tables, that's it. Okay, so we got the 2 and 36, which is way down here. Notice I'm limited to like 3 years. I can't go too far over that because it only goes to 50 payments, and it's separated kind of weird down here, because 5 years would be 60 months, right, in a monthly period and whatnot. So in any case, we're limited to the number of years if it's a monthly as well with the table. So 36, I said it was 36.4902. So we're at 0.4902, adding some decimals, home tab numbers, decimals, and this is from the table. And then we're going to go to the home tab, font, and underline, and that's going to give us our present value, which will be equal to the 25,000 times the 0.4902, adding some decimals by going to the home tab, numbers, couple decimals. Notice this number is slightly different, of course, than what we got here. And well, let's unhide some cells and just double check this. Due to rounding, tables rounded to 4 digits. Okay, let's put our cursor on B, drag on over to K, BK, right click and unhide. So now we've done it this way. We got the 12,255.58. We did it this way with the formula 12,255.58. This is basically the amount that should in essence be on, actually that's not the amount. If you want the amount on the table, you could calculate it this way. It would be the 12,255.58 divided by the 25,000, adding some decimals, home tab, numbers, decimals. That's the amount that would be on the table. Notice it doesn't stop at 4 digits. And when we look at the table, it does stop at 4 digits. That's why we have this rounding difference between this calculation and the table calculation. Note that's not a problem in real life due to it being an estimate in any case, so it won't affect our decision-making process most of the time, but it will be some difference that a school could use to force you to see that you use the table. And then if you don't, they can say, see, you didn't follow the directions, F. And so you don't want that to happen, so be aware of that.